Good things come in small packages. The B650i Aorus Ultra Gaming motherboard. AM5 and ITX is sort of hard. Let's take a look. AM5 launched, and it was sort of expensive at launch. I mean, you were going to get the flagship CPUs and the flagship processors, and then a short time later, AMD came out with the non-X versions of the CPUs. They're 65-watt TDP. They'll work with the old, modest Wraith coolers. In fact, they're bundled with them. I did reviews on those. So now you've got a pretty good lineup of processors you can pick. You can pick the 7950X at the high end, or the X3D, which actually uses a little bit less power and is even better gaming performance. And right around the corner, maybe already out by the time you're watching this video, the 7800X 3D, 8 cores with the 3D V-Cache in the 7000 AM5 generation. I was looking around at ITX motherboards with kind of an eye toward building a home server in the Jonesbow case. And the reason for that, as Serve the Home was first to point out, is the Ryzen 7900 NO-X is sort of a revolutionary CPU in this space. If you're still rocking, an E-series Xeons that you got for $100 at, the discount warehouse or the surplus or whatever, this thing is going to run circles around it. This is 2, 3, 4 times faster. If you aren't interested in the home server use case, stay tuned because this is more motherboard review, and I'm going to have that as a sort of separate build video later because, yes, we take this thing for a spin with the 7950X and the 7950X 3D, and boy howdy, this little thing can keep up. Now, in the landscape of all available ITX motherboards at the time of this video, this was my first pick. Yes, I know there are X670 motherboards available in an ITX form factor, but here's why I don't think the X670 ITX makes sense. The reason that AMD sort of did the chipset the way that they did with AM5 is to give motherboard designers some flexibility and some options for dealing with high-speed PCIe in a relatively low-cost way. You see, the cost of faster PCIe is the majority of the cost increase in motherboards. As the technology improves and the PCB manufacturing process improves, maybe we'll see those come down. But like most motherboards have to be at least 8 layers in order to support both DDR5 and PCIe 5 signaling speeds. Even if we're only talking about PCIe 5 for the M.2, I mean, it's a lot of layers. When you cram a bunch of stuff in an ITX sort of form factor, you may be talking about even more layers than that, depending on the routing and the configuration and so on and so forth. Asus, for example, has an X670 motherboard, and I was wow, they did, and I took a look at it. Doesn't really have more USB connectivity, and they use the extra chipset to power a single M.2. But the madness of that is that connecting that chipset uses the equivalent of a 4-lane PCI Express link. So we use 4 PCIe lanes to provide connectivity for an M.2 that uses 4 PCIe lanes. This is an X670 motherboard in name only, if that's all it's doing. And that's why I'd rather have the B650i, because it's a small motherboard. You don't have to drive signals around the motherboard, as was the benefit with the dual chipset design of X670, X670E. And this still remains PCIe 5 for the M.2. In fact, this is the first ITX motherboard I've ever seen that has 3 onboard M.2, a stack of 2 on the top and 1 on the back of the motherboard, which is great for the home server use case if you're not going to buy a server class motherboard and you want something that's sized ITX, because you can use all sorts of stuff other than M.2 storage in your M.2 slots, as we've shown in the past. You want a 2.5 gigabit NIC, a 10 gigabit NIC, you want a 6 SATA port breakout, foreshadowing, then yeah, you can do whatever you want. So let's take a look at how this motherboard breaks down and how they cram so much into this. Gigabyte did change a few things with the unboxing process. It's a brick. It's a thick brick. If we take a quick look at the motherboard layout, you start to notice that there's some things missing. Don't worry, they're there. They're just there in ways that you don't expect. First of all, you look and there's no SATA connections. Wrong. There's 4 SATA connections, in fact, and it's very hard to find. Most motherboards only have 2 SATA connections at this point for your ITX form factor. But We got a USB 5 gigabit front panel connector, a Type-C front panel connector, physical power and reset button. Where are the LED buttons? Again, foreshadowing. There's no front panel audio connector. Spoiler alert, there is, but it's sort of sideways on the back for the rear I/O. And there's only the one 4-pin fan header? Just the one? No, there's more than that, but again, we'll get to it. There's all this lack of room, and they put a single digital RGB header at the bottom just above the GPU. Okay, well, I mean, yeah. That is a digital RGB header. But hey, what are you going to do? At the rear I/O, we have our Wi-Fi 6E solution, our Q-Flash Plus button, which will allow us to do CPU flash upgrades, because this motherboard was timed before the X3D parts launched, and you will need a BIOS upgrade if you're going to use the X3D gaming V-Cache CPUs with this. We have two red 3.2 ports, our 2.5 gigabit LAN, our Type-C DisplayPort connector, which is 10 gig. We have two USB 2 ports, two USB 3.2 ports, those are 5 gigabit, line out and microphone for analog audio out, DisplayPort full size, and HDMI. At the rear, you're thinking, man, I really wish they could have crammed in some more USB ports. But it would have been tricky to do that, as we'll see in a minute. At the rear of the motherboard, we've got our cutout for our AM5 bracket, not really removable, and then we've got our M.2. So you actually have to take off the motherboard backplate in order to install your M.2, and then it uses the backplate as a heatsink. This is great because if you were running a higher end NVMe like the Samsung 980, it runs sort of hot. It's nice having this big backplate as a heatsink. That is an improvement over previous generations, many previous generations from multiple vendors for M.2 on the rear of the motherboard. A lot of the time those M.2 would run kind of hot. Some of our forum members and some of our past videos, we actually recommended using really thick thermal pads to try to make contact with the case if you were putting it in the bottom of a case, or if your motherboard was mounted vertically and you could get to the back of the motherboard, just go ahead and slap on an M.2 heatsink that would sort of fit in the void behind your motherboard tray if there was a cutout large enough in order to support that. This is going to work a little better in small form factor builds just for that reason, because it doesn't require you to do something exotic for cooling the M.2 in the back of the motherboard. And that is the perfect storage drive, unless you're rocking a PCIe 5 M.2, in which case the M.2 on the top would be a better choice because it has an active fan hidden under the shroud here. You don't have to use that, but it's there for your PCIe 5 M.2 if it needs it. And then stacked below that M.2 is another M.2. 3 M.2. Taiwanese engineering, that's what that is, because this was made in Taiwan. That usually means it's pretty good. And that's just the motherboard, but what else we got in the box? We have our RGB extension cable and this weird little breakout cable. Oh, this is another 4-pin fan header. Yes, because there's not physically enough room on the board, this is a breakout header that you can plug into the motherboard in order to get an extra 4-pin fan connection. Same deal with this header. This header will actually break out and give you two USB 2.0 headers. So you've got 4 USB 2 ports that you can break out and take to rear I/O or use for internal peripherals, like, certain radiators and other stuff. So if you want to have 4 more USB 2 ports with this platform, you can, and that's a huge win for ITX. We've got our detachable, movable Wi-Fi 6E antenna. This is the best sort of antenna versus rubber duck antenna. It's nice to see Gigabyte not cheap out on a... It's not... For AM5, it's a pretty good deal at the time that I'm doing this video. It's about $250 at the time that I'm doing this video, plus or minus, but the landscape of motherboards may have changed by the time you're watching this. We have an additional breakout header for the front panel. And so this also, if you're a cable neatness freak and you want to be able to do your front panel connections behind the area where you can see, like if you have a tempered glass side panel cut out and you want to show off your peripherals, instead of having all of the cables going into the motherboard, you can have these cables go into the motherboard and then hide the front panel connections and other unruly connections like that behind the motherboard tray, depending on what sort of a case you have. This is a really cool feature. Gigabyte first started actually doing this on their really high-end TRX 40 motherboards, and I really liked it for cable management there because you could hide all that, out of the chamber. And I was doing custom loop cooling in my wood grain Threadripper build with a Gigabyte high-end TRX 40 motherboard, and that worked out really well, except for the lack of more CPUs to put in the TRX 40 socket. That part didn't work out well, but still using that platform still works really well. We have a second 4-pin fan header, and then our M.2 mounting accoutrement. Now this motherboard also has a quick release M.2, so you can do it toollessly in the stack, but you still have to have a tool to take the stack apart, so a little odd there. But I like the toolless M.2 where you have a plastic connector. You can just shove an M.2 in there, turn a thing, and it's connected. Now, the pièce de résistance is this. This is a proprietary breakout header that has extra connections for all sorts of fun stuff on it, including 4 SATA ports. This plugs in, snaps in really, in the front of the motherboard here, and snaps in. And this riser gives us our 4 SATA ports. And this gives us some extra connections, including some of those headers for breakout, our extra fan connection, 4 SATA ports, and also even a 5050 RGB header. So you get one 5050 header and one digital RGB header, even on such a small Lilliputian motherboard. He likes that word, doesn't he? Lilliputian. It's all the reviews. Stop remembering things. Just enjoy the ride. Now before I put that board in this case, we're going to have to put it in a regular desktop case so I can slam some GPUs in there and we can do some performance testing and make sure that it performs the way that it should. Well, the results are in and it's basically no compromises. So in our open air test bench configuration, we're looking at a maximum VRM temperature of about 87 degrees C. It's a little warm, but there's not really a ton of airflow in the open air configuration, but it's an open air configuration. Nevertheless, the performance was right where it should be, and that was with our 5950X. That was with burn-in testing, letting it run overnight to get up to a very warm temperature for the VRM, sure. Now in terms of cooling, we're using a Sapphire 360mm radiator. Sapphire's got their debut for AIO. Everybody wants to get in the AIO game. This is a competent AIO cooler, and it's set up on our test bench, and that works really well. Now I know one question you might be wondering about is, what about cooler clearance? This is the really awesome Noctua tower cooler that uses the A12 fans. This is enough to really, I mean, you could run the 5950X on this, and you really, I mean, you lose like maybe 1-2% performance versus the highest end AIO. So if you're super into tower coolers, this thing is worth it. And you got to be thinking, well, with this giant stack of M.2 PCIe 5 heatsink madness, this will never work, right? Wrong. It actually works fine. I mean, it's going to vary a little bit from cooler to cooler, depending on what kind of a tower cooler you're using. If you opt to do a tower cooler with an ITX build, I think most ITX builds are probably going to be an AIO of some sort, which obviously is not going to be much of a problem with this configuration. But I was sort of delighted that the Noctua in its basically default configuration works fine. And you do have millimeters of clearance at the rear I/O because the PCIe 5 thing doesn't sit any higher really than the rear I/O. That's sort of the secret of this design. So depending on what your cooler is or what you're considering for your build, just double check those measurements, but there is ample room around that AM5 socket, even for tower cooler configurations like this. Good job, Gigabyte Engineering. The motherboard didn't do anything unusual. Everything sort of worked as advertised. The 7950X 3D worked as advertised, and the 7900X worked like a champ. The VRMs were quite a bit cooler with the 7900, which makes sense because it's a 65 watt TDP, although it's going to use more than 65 watts, obviously. Gaming performance, even shoving a 4090 in here, which is going to draw a non-trivial amount of power through that PCIe slot, not a problem, not a problem. Didn't really affect the board thermals or any other thermals on the platform as far as I could tell from sensors, or using just a couple of thermocouples scattered around the board. Everything basically worked as advertised. Sort of shocking. One thing that I wanted to check on in the BIOS was to see if I could bifurcate the slot from X16 into 4X4. It doesn't seem like I have the option to do that. So that sort of isn't fabulous for my home server prospects. I've got a workaround for that though, but I'll cover that in a future video. This is just sort of the motherboard introduction, performance build, all this other kind of stuff. So this motherboard is not going to hurt you in terms of performance, even running the highest end CPUs for AM5 that you can get today, which is great. However, there was an anomaly in the benchmarks that I had to go back and check a couple of times, and then I realized what was happening, and then it was obvious. So let me explain. Our B650i Aorus Master. This is a higher end motherboard. This motherboard costs more than that motherboard. This motherboard is slower than that motherboard in benchmarks. How? What's going on? It's down to the memory. And it's not really that much slower. We're talking really minor percentages here. But it is down to the memory timings and the memory controller. This thing only has 2 DIMM slots, 2 DDR5 DIMM slots. Just physically having the slots on there meant that I couldn't quite tune the memory as good. Running 6000 and even 6200 was stable on this, assuming that my CPU was stable. Now 6000 is the sweet spot for AM5. That is an overclock, not really exactly guaranteed. 6200 is definitely an overclock and is way into the silicon lottery territory. But only having 2 DIMM slots really does seem to make everything just a little bit better. So just a 0.5%, 1%, you can eke out a little bit better performance with PBO and letting everything sort of do its thing and optimizing your memory timings just a little bit, as I did with this setup when I was sort of running to see if I could get it to the best of the best. Also kind of trying to force it to get into a VRM thermal throttle situation. It was basically fine. And in case you're wondering about error correcting memory, I'm wondering about that myself. Gigabyte says that it's not officially supported, but I did some things and it seems like it's working anyway with the JetX standard DDR5 DIMM. So I have to do some additional testing, look for the other server build video, and we'll talk more about error correcting memory, the possibility of error correcting memory on this ITX platform. It's a maybe, it's a definite maybe. But you're gonna have to come to the Level 1 forums or stay tuned for information about ECC memory because I've got some BIOS hackery to do. Fortunately, the folks at WinRaid know a thing or two about BIOS hacking, and I've got their help. Fun times. Now things are interesting for the off-label uses for this motherboard. First, the F2 BIOS does actually seem to support working unregistered UDIMMs. DDR5 DIMMs are different when it comes to error correction, and especially registered error correction. We're not talking about registered error correction, these are unbuffered DIMMs. But they are generally available, and much to my surprise, this motherboard not only booted with it, but in Linux I could run DMI decode. Linux kernel 6.1 point something and with the AMD patch set seemed to emit messages showing that ECC was working. That was pretty exciting, although I did not test it extensively. Just because it boots with ECC doesn't mean the ECC is actually working. I upgraded the BIOS on this motherboard from F2, where it was working, to F4. It didn't work after that. It would not post. It wouldn't post in any configuration. I did everything I could to cajole it into posting. It would not post. I don't know why. BIOS bug? Intentional? I don't know. ECC should support, but AMD says these CPUs will support ECC, but it's up to the motherboard vendor to qualify it. We'll cross this one off our list. The F2 BIOS also didn't really properly support bifurcation. It gave you the option, but I couldn't actually get it to work. The newest version of the BIOS, like F4B, would actually support 4x4x4x4 bifurcation of that X16 slot. Can you use this as the world's most tiny VFIO build where you're using the iGPU of your 7000 series Ryzen processor plus an add-in GPU? Basically, yeah, and you've got 3 M.2 to work with, so you can add in other peripherals you might need that way. Separating out the USB controllers and that sort of thing is a little trickier because the IOMMU groups sort of shifted around a little bit with the different BIOS versions. I think we're gonna have to do a separate video on that for off-label uses, but I was disappointed to find that the error correction support went from maybe to no post. But bifurcation is at least fixed on this board, so that's good. Other than that, it's got a pretty good selection of options in the BIOS. Good job, Gigabyte. You can fine-tune the bus speed and a lot of other peripherals. It really does actually give you a lot of control, so that's nice. I don't have a PCIe 5 M.2 to do any kind of PCIe 5 M.2 testing, but I was delighted that turning the fan on and off with my Samsung 980 didn't really make a difference in terms of thermals for the 980 under normal workload scenarios. Now, copying 500 gigabytes of information, the fan on was better, but with fan off, even though the 980 was running hotter, it did not thermal throttle. But 500 gigabytes out of 2 terabytes is only 25% drive capacity. I probably could have gotten it to throttle if I'd copied more information to it, or I'd been harder on the drive, or it had been in an enclosed case that didn't otherwise have airflow over it. But if you're worried about a tiny little fan making a lot of noise, good news, you can just turn it off, and there's not really a bad side effect, at least not with any PCIe 4 drive that I have on hand. So, yay! This has been a quick look at the B650i Aorus Ultra. Gigabyte is back, made in Taiwan. This is awesome. I love this board so far, and genius to be able to cram 4 SATA ports on there, and I really appreciate it. I really appreciate having 4 SATA for builds like this. Even though I'm sure that the vast majority of builds with this motherboard not going to use 4 SATA ports, because who would use SATA in this day and age except for bulk storage? And you're not really going to put a lot of bulk storage in an ITX system, are you? Unless you're a crazy person and have got the Jones Bow case. Like me. I'm Whittless Level 1. I'm signing out, and you can find me in the Level 1 forums. Woo!